So number 4, a cylindrical barrel with a diameter of 2 feet contains collected rainwater. So here's the picture of that. It's filling up with water. So this height is going to be increasing. Well, for a little while, but then water is draining out through a valve that isn't shown at the bottom. So I guess it's raining and it's filling up, but then it's also losing water. The rate of change of the height of the water with respect to time is modeled by this differential equation. So that's the rate of change, dHdt, rate of change of the height with respect to time. Height is in feet, time is in seconds, and then they give you the volume formula for a cylinder. So you don't have to have that memorized. They go ahead and give you that. All right, so letter A, find the rate of change of the volume. So this is a related rate problem. Find the rate of change of the volume of the water in the barrel. So dV dt is our question mark here. And I'm actually not sure if it's going to be positive or negative because the cylinder is filling up with rainwater, but it's also draining out. So I'm not 100% sure. Usually I put positive or negative there, but I'm not 100% sure how quickly it's draining out. Find the rate of change of the volume of water in the barrel with respect to time when the height of the water is 4 feet. So when h is 4 feet, indicate units of measure. All right, so they give us volume equals pi r squared h. And bringing back memories. Yeah, this is back from unit 4, part 2. I split unit 4 into 2 parts because related rates are, just something we need to spend more time in. So this was unit 4, if you want to go back and look at any of that. Now we know what the radius of the cylinder is, and I'm going to throw that question at you guys, because the height of this water is changing, but the radius is not. This is not the incredible growing cylinder. If the diameter is 2 feet, hey guys, what's the radius? Because that's not going to change. That's constant. Yeah, good, 1 foot, perfect. That is not going to change. I can go ahead and plug in 1 for the radius. Now, if you plug in 1 for r, 1 squared is just 1. That's not going to change anything. So our volume is just pi h. So right away, that simplifies this greatly. And then we're going to do the derivative with respect to time. Every variable is with respect to time. So dv dt equals, and then this derivative would be pi dh dt. And they give us a formula for dh dt. It's right here. So I'm going to plug this in for dh dt. So this will be pi times -1/10 square root of h. And then all you have to do is plug in the 4 feet that they gave us. So if you plug in those 4 feet, you get that this is pi times -1/10 square root of 4. You can just leave it like that. And then you have to put units of measure. It's a rate of change. So it's going to be something per something else. And it's rate of change of volume. So I know that this said feet up here for the height, but for volume, it's going to be cubic feet. So feet cubed per second. And I think as far as related rate problems go, that one wasn't too terrible, especially because the radius was constant. It was 1. So that actually wasn't so bad, I feel like, for part A. Now, there was a lot of information that got thrown at you, but I don't think the actual problem we did was too terrible. I always try to give pep talks as we're going through these because I know that they seem kind of scary. I don't think that one was too bad. All right, letter B. When the height of the water is 3 feet, is the rate of change of the height of the water with respect to time increasing or decreasing? All right, so again, the rate is increasing when the second derivative is positive. Rate is decreasing when the second derivative is negative. There was one like this that we did last class. I think it was on question 1 where we had a calculator for that, so we did math 8. Yeah, it was the fish entering and leaving the pond, whatever. Anyway, same thing for this. So we're going to find the second derivative. Oh, whoops, it's not y though, h. All right, so we're going to do the second derivative at when that height is 3 feet at h equals 3 feet and see if it comes out positive or negative. All right, so we're going to do the derivative of this derivative. So it would be -1/10, that's the coefficient, and then derivative of square root. I have encouraged you guys to just memorize that one. If you have that one in your back pocket, it's just a lot easier to deal with. Derivative of square root is 1/2 square root. And then chain rule, you have to chain on the derivative of h, which is dh dt. Exactly the same as we did in part A. Like here, how we had derivative of h was dh dt, it's the exact same idea here. All right, so we had the -1/10, 1/2 square root, and then chained on dh dt. Now dh dt is -1/10 square root of h. So we're going to replace that. We're going to do a substitution here. dh dt is this statement. So I'm just going to replace dh dt with that. And now we have a whole lot of things that cancel here. First of all, the negatives are going to cancel. So it's going to be positive. And then what else is going to cancel, guys? Because I can simplify this a bit further. What else is going to cancel out here? The tens aren't going to cancel. The tens will multiply since they're both in the denominator. Good, the square root of h's will cancel because one's in the denominator and one isn't. This would be like over 1. So the square root of h's cancel. So what's ultra weird about this problem is it says when the height is 3 feet, but it actually doesn't even matter. The height could be anything because the h is canceled out. All we're left with is a 10th times a half. That would be a 20th. And then times a 10th. So 10 times 2 times 10, that would be 200. You get 1/200. There's no variable in there. You can't plug in 3 because the h is canceled out. And this is positive. I know it's only 1/200th. It's a really small positive number, but it's positive. So our conclusion is the rate is increasing. And you can say at h equals 3 feet if you want. It kind of doesn't matter. It's increasing all the time. Because second derivative is positive there. But you could even just say the rate is increasing all the time. Like you could say always, because second derivative is positive all the time. The only reason I'm bringing up the 3 is because they wrote it in the problem. But again, it kind of didn't even matter because that variable canceled out. The first time I did this question when they released these, that threw me. I'm going to be real honest because I was like, well, what about the 3? It was kind of extraneous information. So you kind of didn't even need that. All right, and then letter C, at time 0 seconds, the height of the water is 5 feet. So that's an initial condition, 0, 5. Use separation of variables to find an expression for h in terms of t. All right, this is just solve the differential equation. This is like the last unit we did. I'm going to rewrite the problem here so we can see it a little bit better. Get rid of this piece of paper. All right, we're just going to solve this differential equation. So first, separate the variables. We're going to divide over the square root of h and then multiply over the dt. Now, before I do the antiderivative, I'm going to rewrite that 1 square root of h. I can rewrite that as h to what power, guys? I'm going to throw that one at you guys. H to what power? It's a square root and it's in the denominator. So that would be h to the what? I'm going to wait until I get a few answers here. Because you are going to need a 1/2. Good. So the 1/2 is because it's a square root. We do need a negative because it's in the denominator. That's why I threw that question at you guys, because I know that that is tricky. All right. So it's a fraction and it's negative, which is like double whammy here. Right. Fractions bother people and negatives bother people. And this is a negative fraction. So just, buckle up. All right. Antiderivative. We're going to add 1 to the power. So -1/2 plus 1 would be +1/2. So that's cool. It's not negative anymore. That's good. You add 1, and then you're going to put the reciprocal of that out front. So 2h to the 1/2. Over here, antiderivative would be -1/10 t plus constant. And we're going to plug in the initial condition, which was 0, 5. So we're going to plug in 0 for t. That means that's gone. 5 for h. Now you can rewrite this h to the 1/2 as square root of h if you like that better. This would be 2 square root of 5, or you could leave it as 5 to the 1/2, whatever your preference is. Right? And then we're going to recopy this line but put that 2 square root of 5 in as the constant. And then your last step is get h by itself. I'm going to actually just do some erasing and not have to rewrite this. We're going to divide over the 2. So all of that gets divided by 2. And I would honestly just do that. I think that's easiest. Just leave it alone. Divide it over the 2. And then to get rid of the square root, we're going to square the whole thing. And so h equals that mess. Again, if you get something that's a complete disaster, you probably did it right because these tend to be a mess. All right, let's go over the points for this one. Again, it should add up to 9. I should say it should add up to 9 as though there's a possibility it won't. It is going to add up to 9 points. So for part A, let me see here. If you did this derivative, you get a point. And then it's a point for the answer with the units. So if you got the right answer and left off the units, they wouldn't give it to you. There's no half points. You either get it or you don't. Like if you accidentally didn't write the pi, they would not give you the point at all. So you got to be really, really vigilant. All right, down here you get a point for, let me see how I have this written here. So you get a point for the derivative. You know what, let me look at the scoring guideline real quick because I don't want to say this wrong. I just kind of marked a point on my paper, but I can't remember exactly what it was for, and I don't want to tell you wrong. So hold on 1 second. It'll only take me a minute to look it up here. So you get a point for, how do they have this written? They have it written really strangely. Oh, it's a point for, it's a point for doing this derivative. So basically knowing that the derivative of square root is 1 over 2 square root, and then it's a point for the chain rule. So like chaining that on. So basically it's 2 points for that derivative is what they're doing there. Yeah, knowing that this derivative was 1 over 2 square root, and then another point for doing the chain rule there. And then it's a point for explaining your answer. All right, and then for part C, sorry, I can't see both what I'm writing and this other window open at the same time. All right, so it was a point for separating the variables. It was a point for the antiderivatives, so getting to this step. It was a point for getting what C is, and then a point for solving for H to Z.